Hello everybody and welcome to your next Sfml tutorial. So in this tutorial we're going to be learning about gravity. Now if you've watched my Lego HD tutorial series, then the code here is going to be fairly similar. But there's a few little things here and there that are a bit different. The concept is the same, it's just the syntax is slightly different. So let us look into this code. Now, first of all, this code might look familiar, might not look familiar to you. What you need to do is load the code from the loading tile maps tutorial. Each tutorial is fine. It doesn't really matter. We just need a map, and that's all we need. We just need a map. Well, you don't really need a map if you really don't want. You really don't need it. But it's cooler to have a map just to see your gravity in motion. So once you've got your map code done, or whether or not you don't, we need to go to our main function. So in our main function, what we're gonna do is we're gonna create a rectangle, and yeah, we're gonna name it rect, and we're gonna load our map, and then we're going to have two vector 2's, and this is the part that's different than the Lego version. So we have two vector 2's for our player position and our player velocity. Okay, so our position is our position on the speed, and the velocity is going to calculate how fast and which direction the speed at which our player moves in a given direction. Okay, so we have a constant float called gravity. Since gravity is always constant in the real world, then it should be constant within your game. Even if you have something that alters the gravity within your game, you should have another variable or something. Like say you have another variable called gravitational pull, and you say gravitational pull is equal to gravity plus the pull value or whatever. You could always do that. But yeah, gravity should have a constant value. It doesn't have to be, but in reality, gravity is always constant. So for our ground height, I set the ground height is equal to map size, the vector size minus 1 times block size minus block size. If you're using the easy or the intermediate map size code, then the ground height will be equal to the map size y minus 1 times block size minus no, it will be equal to, sorry, map size y times block size minus block size. Or you could do map size subtract 1 times block size without this right here. And if you don't want to have the minus thing right there, then you can, sorry, then you can easily, for the vector map tutorials, and you can just do -2, and then your player will land the correct position. Now we have two other variables here, our jump speed and our move speed. We set our jump speed to 10 and our move speed to 5. And we have a Boolean variable called jump, and this Boolean variable, if jump is equal to false, that means that your player's in the air and that you cannot jump. If jump is equal to true, then that means your player can jump, meaning that it's on the ground or on a platform or on a solid surface. Okay, and then we set our position equal to our player position. So right here in our update section, we say if the player is pressing the right key, then we set our player velocity x equal to move speed, not plus equals, not minus equals, just equals. Else if they're pressing the left button, then we set the velocity x is equal to negative move speed. Else, then our velocity x is equal to 0. So if we're not pressing right or left, then we're setting our velocity equal to 0. If we look right here, we have another if statement, not else if we're pressing the up key and jump is equal to true, we set our player's velocity y equal to negative jump speed because we want it to move towards the top of the screen, and then we set our jump speed equal to false. No, we set our jump equal to false, sorry. So now we have two things here. We say that if our jump is equal to false, then our velocity y plus equals gravity, and if jump is equals to true, then we set our velocity equal to 0, and then player position plus equals player velocity. So this is equal to saying player position x plus equals player velocity x, and player position y plus equals player velocity y, but you're doing this all in one line. So it makes it a bit cleaner. So let us explain what is going on right here, okay? So first of all, let's say our ground height is equal to 600, okay? So if the player presses the up key, okay, player velocity y is going to be equal to negative jump speed. So player velocity y is going to be equal to negative 10. And we're going to set jump equal to false. So it says if jump is equal to false, then player velocity y plus equals gravity. So therefore, player velocity y is going to be equal to 9, okay? So no, it's going to be equal to negative 9, sorry. So then the player position is going to be player position y plus equals is going to be player position y plus equals negative 9. Then when we loop again, it's going to say player position velocity y plus equals gravity. So since our gravity, our gravity is 0.1, so at first, our player velocity y is going to be 9.9, and then when we loop again, our player velocity y is going to be negative 9.8. So therefore, our player is going to be moving player position y plus equals negative 9.8. So it's going to be moving towards the top of the screen, but every single time it loops, it's going to be moving slower and slower towards the top of the screen. When it reaches its peak, meaning that player velocity is equal to 0, then it's going to start moving down from there forth. So then when player velocity y is equal to 1 or 0.1 or something, or positive 0.1, then it's going to start moving down towards the bottom of the screen. And each time it loops, it moves down gradually faster and faster and faster, and therefore you get a more realistic gravitational pull in your programs. Now, if you're one of those physics junkies and you really want to have maximum physics, you can also use box 2D within your programs, or you can use the actual physics formula. I think it's Newton's law of physics. I'm not really sure. Don't quote me on that. But you can always use physics within your program if you like to. So yeah, that's really up to you. And just to show you, the bit of the code for the rectangle. So yeah, that's just for the draw map function from the previous tutorials. But yeah, so we do that. So we know, we calculate our gravity. So whether we jump or anything, we're gonna land back at our ground height. So how do we set the ground height, or how do we know if we're on the ground or not? So if you've noticed in our if statements and stuff like that, the if statements are basically, they return a Boolean value if they're true or false, much like a while loop or a do while loop or something. So for example, if I say if 1 is equal to 1, then this statement returns true. But if I was to put if 1 is equal to 0, then the statement will return false. So a statement, these conditional operators right here, this is what they're called, they return a Boolean value, whether it be true or false. Our variable jump is of a Boolean type. So instead of using an if statement, we can easily say if player position dot y plus 10. Oh, and the reason why I'm doing this plus 10 is because that is the height of the player. So we want to check if the bottom of the player is touching the ground. So anyways, if I could easily put if it's player position y plus 10 is greater than or equal to ground height, then jump is equal to true. And then I could put else jump is equal to false. But that is a waste of so much code. There's many ways to do there's multiple ways to do conditional operators. You could use if statements. There's also one, I don't remember what it's called, but it's one involving the question mark and stuff like that. You can utilize all of them within your program, but this is a very simple way to incorporate it. So it's saying that if player position y plus 10 is greater than or equal to ground height, then this whole statement is going to be equal to true. So if this statement is true, then jump is going to be equal to true. If this statement is false, then jump is going to be equal to false. So if the player is basically touching the ground or is below the ground, then jump is going to be equal to true. We say if jump is equal to true, then player position y is equal to ground height subtract 10. So the player is going to be on the ground. and then we set the position, etc., etc. And then we draw the rectangle to our screen. We draw the rectangle after we draw the map, and then we draw the player, and then everything should run smoothly. So no, this is just colliding with the ground. There's no platform collision or anything. I'm not going to be showing you collisions in this tutorial series. That will be for the advanced platformer series, but yeah. So in our program, our player will fall to the ground. Sorry, I never increased the window size, but yeah, the player falls to the ground. The player can jump, and then it will land accordingly, and it will look like you have a gravitational pull in your game. So that is it for this tutorial. Hope you enjoyed it. Thanks for watching. The source code is already on the website, so you guys can get that as well. So thanks for watching, and bye.